Muscle contraction.
Muscle contraction occurs every time the muscle must contract in order to move the bone that is attached to or to provide resistance against the force. There are different types of muscle contraction. Isometric. Load varies but muscle length remains the same. Pushing head against arm is an example of an isometric contraction. You can push with various amounts of force but the head does not move.
Isotonic contractions are the types that produce movement. Strength does not change, but the joint angle does. Lowering a heavy weight at a slow and constant speed is an example of an isotonic contraction.
Isokinetic contraction is the action that occurs when the speed of shortening of the muscle remains constant over the entire range of movement. Maximum force can also be exerted at all joint angles of the movement.
Happens within fractions of a second. First off, the brain sends a message or nerve impulse to contract down the spinal cord to the motor neuron and then to an axon terminal. The synaptic vesicles in the axon terminal releases the neurotransmitter acetylcholine or ACH into the synaptic cleft through exocytosis. ACH binds with ACH protein receptors on the sarcolemma, stimulating a muscle impulse. The muscle impulse, also known as the action potential, passes in all directions over the sarcolemma. The T-tubules allow the impulse to pass deep into the muscle to the sarcoplasmic reticulum, or SR. Depolarization of the T-tubules release calcium ions.
From there, calcium ions diffuse from the SR into the sarcoplasm and bind to troponin, causing it to change shape and become erect, pulling on trypomyosin and exposing the binding sites on actin myofilaments. This allows the myosin heads on the myosin filaments to bind to the exposed binding sites on the actin myofilaments, forming cross bridges. Think of people playing tug-of-war against a springed wall. The people's hands are the myosin heads, the rope is the actin, and the wall is the Z-line. The myosin heads move the actin towards the center of the sarcomere. This releases ADP and a phosphate from the myosin. ADP then goes back to the mitochondria for recharging. The myosin continues to pull on the actin and shorten the sarcomere. This is called contraction.
But our muscles don't stay contracted. So what about muscle relaxation?
Well, I guess this is where I come in. Muscle relaxation, right? This is how it works. Alright, so the ACH that started the contraction is quickly broken down by the enzyme acetylcholine esterase. This enzyme is found in the synaptic cleft. Muscle fiber is no longer stimulated and relaxation can now occur. Calcium ions are rapidly moved back into the SR. So now let's go back to the tug-of-war against a springed wall analogy. The actin is the rope and the myosin are the people. When the people let go, the wall, or the Z-line, springs back into the original spot. This is because ATP causes links between actin and myosin to break. ATP, however, doesn't break down. The calcium or troponin complex is taken apart, troponin and tropomyosin interact and block the binding site on actin. The muscle fiber relaxes, ATP breaks down the myosin cross bridges, and the muscle fiber remains ready for further stimulation. And that's how it works.